we are back. I'm going to keep the hat off for the remainder. Not that it's not fun to have it on, but it's just better, easier to have it off to a degree. But yeah, welcome back, friends. Okay, and then let's see whether or not I'm coming in okay. Okay, cool. Yeah, sorry, I screwed up. I needed to have a little scene transition so I could go do humanly things. So, not realizing that couldn't just leave the video on. So, didn't want people to see. I have to figure out how to do a blur in the back or something like that, some zoom type of thing or some background related thing. Or whether or not we can actually get that going. I don't know. But anyway, we're going to get into the tutorial. See, the tutorial looks good. I actually do like this. Um, all the everybody loves right? They love it when people go when they hear them. Yeah. Shell completion. Yeah. Not much going on there. I this is what I do like about the more you read it every day, the better you get at something. And I think this is this is, as somebody who was and is some in some way still a teacher. This is what gets me. Everyone's trying to shirk the responsibility of learning. And people have been doing this for a day and an age, but it most harms I see it most harmful when people are trying to put out, hey, I can do X, Y, or Z, and they can't because they didn't just go through the work to actually be able to do X, Y, or Z, right? Um, it's the same thing with programming. The same thing with anything. If you say the robot lifted all the weights for me, that means you didn't actually lift any of those weights. That means you're not as strong as you thought you were. It's not as good as you thought you were. I do martial arts. You can definitely see a lot of people who say they do a lot of things and they don't actually do anything. Real pro. He's a real human being, and this is why I think everyone should spend time going through the documentation. Not fast, not in one day, over a week, over a month, over 3 months, right? You want to get something on your resume, it's not going to be a week or 10-hour tutorial on YouTube. It's going to be a lot of practice. I feel great with Ruby, but there's still a lot of things I don't know. And there's still a lot of things I want to know. So get to learning. Like me. Learn along. Come on, it'll be fun. Let's complete this example. So the following example is a complete Ruby program. You can run it and see the effect by specifying various options. This is probably the best way to learn the features of OptParse. So let's go. I don't know if Twitch will. No, I don't think Twitch picks up any music that I play. So I'm gonna play a little background just to not be so lonely. Or I don't know. Hey, stop by, say hi. All two people who are supposedly watching. Hey, say something in the chat. It'd be cool, right? Um, let's get down to it. I'm gonna throw a little music on just so I feel good about myself, and then now that makes me feel all that great. Yeah, let's do it. All right, let's require. Right, we need to always require the OptParse. We'll keep it single quote for now. opt parse time acquire obstruct. Oh no, there's an obstruction in the bell wave. PP. All right. So class opt parse. Let's name this one real opt parse version 1.0.0. Leave that as is. Codes. JA, it's not JP. Country code for Japan. Use what? Okay, hold on. This is not something I quite understand. What is this? Nihongo. Okay. Back into this. Keep it to 25. Shift. JS. UC. JP. UTF. 8. Binary. Yeah, we're going to do this because we need to know what's going on here. Yes, you would probably just create something to handle this most of the time, but this is why it's learning, kids. 25. Can we do this in 22.5? Yeah. Okay. Not bad, not bad. Yeah. No, I'm not going to bother to translate for that for you. If you don't know, you don't know. I'm just looking up how this if we still have 20 if this is still relevant for 2025 not 25-25. We're not there yet, but I'll still be around by then. Who knows? Script options, right? And then we do our good old ter accessor, right? Ooh, we get to put a lot of things in here. See, that just amazes me. We can just leave that as is in place. Why are we? There we go. Xiong. I said delete, delay. Time. Okay. Then we're going to do our initializers. You're thinking in Python too much, John. Free your mind. Self-encoding. Self-transfer type. Verbose. Yeah, I gotta do that tomorrow. So that means there'll be no stream tomorrow, unfortunately, because Uncle John's gotta get some work done. But Tuesday and definitely Wednesday, we will be streaming. So it's all good. Okay, so we can buy the initialize, and then oh no, it's long. Whatever did we do? Okay, define options parser, right? Parser banner equals usage, right? And so this is called real pro, not RB, right? Options. You got options, kid. Parser dot separate. I don't want that there. Specific options. Now we have options. Delay performance in place option parser. Delay execution. Execute time specific. So we can add additional options here, but that's okay. So we'll leave those for now, but they're just additional options. So we're going to get right into, for example, parser separator. Gotta keep it separated. And common options. Uncommon options. Who wants common options? I think we'd all prefer the more uncommon kind. Parser dot on tail h, right? Help message do. Let's parser exit end. Alright, so we can do other stuff here on tail. Kick off my slippers. Sit down right here. So we have our options. We've defined some options here. List example option, specify record. Okay. So we can do parser. Right there, guys. Parser dot on tail version No, that's not what we want. Puts version. Exit. Right, so this ends. Define option. Object here. Right now we can do perform in place option. Right, and then in here, right? So this calls, this puts our options in here. Okay. Let's, in fact, do those then, because then we're going to need them. So def. Oh, they're already here. No. Def there. Delay. Execution. Time option. Yep. Excite at time. Execute. Tell you how you spell excite, right? Specify record separator option parser list example option parser specify. So there are no, stupid, you just wrote it twice. So there is white spacing that happens here, but it's not. Optional option argument. Optional dismemberment clauses. Option argument with keyword completion option parser boolean verbose option parser. Right. In place, not a known word, unfortunately. Unfortunately for in place. All right. Let's get her done. Parser on, Blaine. Place. Make backup. Nope, not what we want. Nope, not what we want. Nope, not what we want. Okay. Hang on. Nope, not what we want. No. Why do I always screw this up? Nope, not what I want. Big, not what I want. Nope, not what I want. Not what I want. Definitely not what I want. I'll be back on this. Open that up. Get out of here. Second time this has happened. Yeah, I'm stupid, I know. Nope, don't need that right now. Alright, cool. I fixed that. You see, it is this like stupid little. Whatever happens when I go. This is all part of learning, so I do this or do this. Something happens. See, that's just doing a line copy, right? So if I do that, that's not a problem. But if I do something like, so if I'm writing, you're not really writing, you're just, yeah. Extension. Supplied, right? Do. Bam. Alright. We wanted this to be on the same row as parts. In place equals true. Self extension equals next or nothing. It's nerf for nothing around here. But where is, yeah. That really shouldn't be a problem then. Extension dot sub. Yeah, no, I'm in the right place. Nope, you screw that up again. Yeah. Alright. Boom. It's gotta be here. Otherwise, yeah, I read the line wrong. Was true. Extension close xt pipe or nothing. Extension dot sub. Forward. Nope. Forward slash. Backslash. No. Backslash. A. Backslash. Dot. There we go. See, the problem with having a double language keyboard sometimes is that you end up not really having access to everything. Not everything is in the place you want it to be. Yeah, I guess that all works. Alright, then we'll go. Okay, that all works out. So to recap on what we've done so far, right, we started up the option parsing through Ruby. And right now we're doing what they call the best way to possibly learn a feature. Now I'm not entirely sure if that's the best way to learn the feature of opt-parse, rather. And we just got done here, so we can just go and according to what they say. Now we can define so this casts time the argument at the time object. Parser on t time for time. Time after time. Time after time. Execute. Time. Do. We're going to do with time here. Self.time equals time. And same thing, def specify records. Option parser. Parser on. So if anything we've learned today is using parser on. Now before we move on to the tutorial, I want to go deep in on how our on is used. Because my bad memory or whatever is not recalling whether or not this needs to be inside. Defaults. Self dot record separator equals this is kind of the beauty of Ruby right here, my friends. Just being able to make this little object happen here. There's not a bunch of kind of jargon or anything. It's all right there. You can do parser on. You got all this fun stuff that goes on inside of it, right? While you're doing something, then it calls itself with the RS, right? I really like that. Even if I'm not entirely 100% sure what's going on here. Not 100%, but still. You like something you like. The brain likes it. List example option, parser. List of X, Y, Z, array, example, list arguments, do. Okay, cool. Some people are just watching me copy paste. See, the thing is, this is not copy pasting. This is muscle memory. This is practice of muscle memory. Right? Will you necessarily do everything here the same way every time? No. Are you seeing how it's being done, however? Yes. That's valuable. Someone not seeing the value in that, that's on them, not on me. Now, do you want to watch someone do that? Sure, you can. Also do it yourself. and follow along. It's fun. Def specify encoding. Fine encoding. See, this should already be no. Example options, encoding option. Parser. Yeah. Copy that. Keyword completion. We are specifying the specific set of codes and code aliases. Notice the latter is a hash. The user may provide the shortest unambiguous text. So code list equals code alias dot keys plus codes dot join. I do like how join is pretty universally the same among most languages. Pasa on. Get to the pasa! Mac! Get to the pasa! Coding. I was finding myself earlier today. Yeah. I was finding myself earlier today going $sign on this stuff. Which, I mean, I don't know. That's not necessarily a bad thing. I totally see why you want to do hash instead of $sign. Because America and all that other stuff. Encoding, let's put then the rest of that inside of here. But nope, the program don't go inside of there. That don't know happen now. And then this has got to go outside. Yeah. Wait a minute. Parser on. Parser on, Wayne. Parser on, Garth. Okay. That's kind of working. Go end. Then we go. No. We don't. That's not. Yeah, we gotta go here. We gotta go self. We gotta go encoding. Then we gotta go encoding again, just for our own. No. That's not what we want because we need two here. What is going on? Right. That's not where that's supposed to be. That's still pushing itself out there unless I push it back this way. Yeah. Huh. Am I wrong in just thinking that? Yeah. That's. Okay. See if it runs. If it flies, it dies. Okay, we got two more. But we did not put specifying coding options. right, 2 more there. Because I feel like this is probably a good way to look at how it's a good way to see how stuff works out. But the problem with it is devoid of context. So it is devoid of, do we see what's going on here? Yes. What are the options? Yes. Do we have a thing to go like that we're actually doing? I guess. So it's good to see you're seeing the workings of it, but you're not really seeing what what the use of it is. So like knowing what the binary is, knowing what the auto is, right? Those are all good things to work on or things to know. That's not what we want. And that's why doing this can sometimes feel a little sloggy because hey, if you don't really see, because right now I'm typing this out, right? And yeah, I can do this all the live long day, but doesn't really mean the transfer type equals t. Right. So optional argument with keywords and completion option. Right. So this temp. So optional type option argument with keyword completion. Right, and then we go and here. And the last one, def for post option per. Nope. There it is again. And for the third time on this stream, you'll see me panic in terror. Okay, I don't want to quite screw this up. Okay. Do that there, do that there, do that there. Do that here. Gotta actually figure out how to get out of that. No. Post. Run the verbosity. Do the V. args. Options. Script options. Done new. Args. It's going to be equal to option. Parser. Done new. Not that new, but done new. Do. Parser. Options. Define options. Example equals. Call this the real. It's a real one. As opposed to all those fake ones. It just comes back to RGV, ARGV. What is the PP and what is AR? These are two things I am not clear on. So before, what is PP? Then we're gonna find out for the other two things in here that we didn't quite know in the beginning. Obstruct or obstruct. I'll obstruct you and then on. Right. Those are three things we're going to look at before we go into the tutorial in earnest. But, alright. Let's see if we screwed this up or not. So, let's see. Ruby CD DC. My stream has become an official part of the DCU. Because that's no longer around. We'll see if James Gunn will take me into the DCU. He seems to be okay with everybody else coming in. Ruby Real Pro RB. So we got a bunch of syntax errors. Do RS. So what is the problem here? So the real issue is 67. Ah, that's why. It's gotta go outside. Let's try that one more time. Really right obstruct. We really did right obstruct there. That's hilarious. All right. One more time. Define options. God, I love it. 102. Define options. No. All right. No, this is 25. Now, parser separator. This is part of the. No, that's not what we want. Want you over. Want you over. No, we don't want you here. We want you here. We want you here. No, that's not what we want. Come on now. Somebody play nice. Okay, cool. There we go. What is. Yeah, because I have to debug the. Oh, because this doesn't need to equal. The separator is just like that. Okay. Let's see what else happens. This is just. Now, this is just getting fun. Might not be fun to watch, but I'm finding it hilarious. Delay execution. Because there's nothing like finding errors, like finding your own errors. 102. Delay execution parser. 29. Delay execution parser. For an undefined method for delay execution. It's not actually called, is it? Delay execution is not. Nope, we didn't actually do it. Perform in place there. Delay execution. Not there. So let's put. Okay. I'm assuming. Stop doing that. Even if you're doing code copying, this is a good way to. This is what debugging should be, right? Debugging should. You can say you can give it a cursor or whatever, and it can give you all sorts of stuff. Even in a case like this, it is better to just look at it on your own and see if you can make something work, right? Because it's teaching you to read the damn lines. And if you don't read them, what good is it? And okay. Now, what I did was probably not a great move because you want to always be 58. Script options, local variable method parser. But there's nothing here. Seriously. Place. Like, this should have been the first. Oh, wow. Okay. That's where that got screwed up. So, just go here. That should. Delay execution. Okay, no. Hang on. That should fix that. Yeah. I gotta be looking like amateur hour right now. This is just fun as now, isn't it? Parser? Parser? Did you mean parser? 9. This is just getting funnier by the second. Eesh. My best commenter is a Hilariously likely a bot. Oh well, it's all bots on bots these days anyway. The Great Robot Wars. It's 109. No, that's supposed to be part of this. Parse? Did you mean parse? Alright. Hoo hoo. Hello. Let's take a look at this. Okay, cool. Looks like it now runs okay. Cool. Alright. So we're hitting the close to our point. So what we're gonna do. I don't want to start in earnest the tutorial today. But what I want us to do. We still don't even get to Thor yet. So let's review, shall we? You guys got to see me completely flail at this. But flailing's all part of the learning process. Not this one, a real program, supposedly. So we'll break this down. So the whole thing starts here, right? We get all our little performance checks, right? All sorts of different stuff. Then once we get out of this, right, and then this calls everything, or this gets all actually parsed, right? And in our little tags here, right, we get the script options, the option parser, right, defines the options, all this fun stuff. Creates this out here. Now PP, hilariously named. Hilariously named. Not what I want. Get out of here. I said get out of here. Ruby programming. Because we don't want something else coming up. Holy Christmas, we would not want that. It's a pretty printer. Okay. Could have called it something else. Pretty printer. That's a gem. We actually don't have this installed. That's not how you install that, Mr. John. Or we don't do that here at all. Huh. Guess not. Let's see. I haven't used bundle because I keep on. Oh, this is why. Because I keep on grabbing this. I gotta uninstall that. bundle. Okay. So I haven't mastered gems yet. I know need to do a deeper dive on the kind of a difference between NPMs, packages, and gems. I feel like they're the same thing, but they're really not. Gem being a package manager seems a lot more tenable than other stuff. But I mean, it's like when people said Go is a really unreliable language. Ah, it's so insecure. I mean, it feels like all of them are that way. Now, what is obstruct? Obstruct. Obstruct. Ruby. Open struct implementation. An open struct is a data structure similar to hash that allows the definition of arbitrary attributes with their accompanying values. See, isn't that beautiful? It's just right there in the description. Person name. Cool. I like that. All right. How about nope, can't get that specific. Tutorial classes. Bring me home. Documentation. Modules. String. There we go. No. On head, on tails. That's funny. Okay, cool. Well, we got something to run at least. So what we're gonna do now is, you know what? I think what I'm going to do is just allow our Ron Swanson to run. We already have this saved somewhere. We don't need it. Oh no. Okay, that's gonna do us for that for right now. No, we don't need that. I said I'm gonna leave this here for now, so everyone can view it. I am gonna get a little water. Actually, see whether or not. Okay, and then we're gonna add. Okay, so we are going to cut to Ron Swanson for probably 5 minutes. And I'll be back and I'm going to read us a little bedtime story. See ya. Can I just? Oh yeah. Quick transition. Go. That didn't work. All right. Okie dokie. So I hope you all enjoyed that break. Just getting a couple things done. So, as promised, we are gonna go back to reading Wise Poignant Guide to Ruby. This is going to be kind of our bedtime story for today. We're going to try to get through most of this. He is a hilariously verbose writer. We might go through some of what he has to say here. So I think we'll probably try to get to 5. We'll try to get to here, but I'm not promising anything. So I grabbed myself some water. So we're ready to go. I might. What does it say? 3. Alright, because we start off with about this book. Right, and then he goes, Konnichiwa. He does this very weird thing where I'm going to again say, oh, it's kind of freaky. So it's this. He does this mid 2000 or mid 2000s should have been dead in the 90s kind of like, oh man, it's weird, it's from Asia type of deal. So all right, whatever. I still think his book's entertaining, so it's worth going through. So let's go through it, shall we? A quick and hopefully painless ride through Ruby with cartoon foxes. I can't believe I got up at 8 o'clock for this. You're telling me? What's more, I haven't seen a check yet. So they said I don't get paid until the book is done? I got 50% up front. What a racket! I'm telling you, you totally have a hard line. You totally have to hard line these guys. These two. These are the two. My asthma kicking in, so I've got to take a puff of medicated air just now. Be with you in a moment. This guy would just be a streamer now, I think. He would just be like an internet guy. I feel like these guys, they really had to show something back in the day in order to get publisher to give you money, but still. Well, what's with these little boxes? What kind of crap conditions are we in here? No legs. Cripes! Holy, where are my legs? Yeah, you're on the Photoshop clipboard. What? What if Photoshop crashes? Pray it's OX. Oh, it's Ox. Pray it's Osks, man. I'm told that this chapter is the best accompanied by a rag. I'm told that this chapter is best accompanied by a rag. Best accompanied by a rag. Something that you can mop your face with as the sweat pours off your face. Indeed, we'll be racing through the whole language, like striking every match in the book as quickly as possible. Like striking every match in a box. They also come in books, too. Language. And I mean language. Ruby is easy to read. And that's my line. Is this like some sort of infomercial? Like an info book or a book commercial or something? Our careers are so over. Is he eating the book? My conscience won't let me call Ruby a computer language. That would imply the language works primarily on the computer's terms. That the language is designed to accommodate the computer first and foremost, and that therefore we, the coders, are foreigners seeking citizenship in the computer's locale. It's the computer's language, and we are the translators for the world. But what do you call the language when your brain begins to think in that language? When you start to use the language's own words and colloquialisms to express yourself. Say the computer can't do that. Say the computer can't do that. Better way to read that. How can it be the computer's language? It is ours. We speak it natively. We can no longer truthfully call it a computer language. It is Coders speak. It is the language of our thoughts. Read the following aloud to yourself. 5-point times. Print. Ole. In English sentence, punctuations such as periods, exclamations, and parentheses are silent. Punctuations adds meaning to words. Helps give cues as to what the author intended by a sentence. So let's read the above as 5 times print, ole, which is exactly what this small Ruby program does. Beck's mutated Spanish exclamation will print 5 times on the computer's screen. Beck's mutated Spanish. Huh. Then that's dead. Look into that later. Read the following aloud to yourself. Exit unless restaurant. Include aura. Here, we're doing a basic reality check. Our program will exit. The program will end unless the word restaurant contains and includes the word aura. 2025 kids are reading aura much differently than they were in 2005. Kids, we did not have this thing called aura farming or whatever you're calling it these days. Again, in English, exit unless the word restaurant includes the word aura. Ever since a programming language use of question marks so effectively, ever seen a programming language use question marks so effectively, Ruby uses some punctuation, such as exclamations and question marks, to enhance readability of code, or of the code. We're asking a question in the above code, so why not make this apparent? Read the following aloud to yourself. Toast, cheese, wine, each, food, print, food, capitalize. While this bit of code is less readable and sentence-like than previous examples, I'd still encourage you to read it aloud. While Ruby may sometimes read like English, it sometimes reads as shorter English. Fully translated into English, we might read the above as, with the words toast, cheese, and wine, take each food and print it capitalized. The computer then courteously responds as, toast, cheese, and wine. At this point, you're probably wondering how these words actually fit together. Smooch Kiss is wondering what dots and brackets mean. Who is Smooch Kiss? I'm going to discuss the various parts of speech next. All you need to know thus far is Ruby is basically built from sentences. They aren't exactly English sentences. They are short collections of words and punctuations which encompass a single thought. These sentences can form books. They can form pages. They can form entire novels when strung together. Novels can be read by humans, but also by computers. Very good point. The parts of speech. Just like the white strip down a skunk's back and the winding white train of a bride, many of Ruby's parts of speech have visual cues to help you identify them. Punctuation and capitalization will help your brain see bits of code and feel intense recognition. Your mind will frequently yell, "Hey, I know that guy!" You'll also be able to name drop in conversations with other Rubyists. Try to focus on the look of each of these parts of speech. The rest of the book will detail the specifics. I will give a short description of each part of speech. But do you have to understand the explanation? But you don't have to understand the explanation. Do you? Don't you? My brain read that as a question. By the end of this chapter, you should be able to recognize every part of a Ruby program. It's amazing that he actually, back in 2005, 5, and I'm not sure if programming books did this prior to that, but he's going through we have to do everything first. And this is if you do any sort of programming anywhere, it kind of gets to this. Variables. Any plain lowercase word is a variable in Ruby. He didn't capitalize Ruby there. Variables may consist of letters, digits, and underscores. X, Y, banana 2, or phone a quail are examples. Variables like nicknames. Variables are like nicknames. Remember, when everyone used to call you Stinky Pete, people would say, "Get over here, Stinky Pete." Everyone would miraculously knew that Stinky Pete was you. With variables, you give a nickname to something you use frequently. For instance, let's say you run an orphanage, and it's a mean orphanage. And whenever Daddy Warbucks comes to buy more kids, we insist that he pay $121.08 for each kid's teddy bear, which the kid has become attached to over in the darker moments of living in such a nightmarish custody. Teddy bear fee equals 101.08. Later, you ring him up at the cash register. A really souped up cash register which runs Ruby. Back in 1923, you'll need 1930s, not 1920s. You'll need to add together all his charges into a total. Total equals orphan fee plus teddy bear fee plus gratuity. I feel like Daddy Warbucks would not actually pay for this. Those variable nicknames sure help. In the steady underground of child sales, any help is appreciated, I'm sure. Man, his examples are weird. Shh. $121.08 ain't a bad teddy bear fee. Numbers. The most basic type of number is an integer. A series of digits which can start with a plus or a minus sign. 1, 23, or negative 10,000 are examples. Commas are not allowed in numbers, but underscores are. So, if you feel you need to mark your thousands so the numbers are more readable, use the underscore. That is something I've learned. I did not know you could do that, which makes me a bad programmer, I guess. Decimal numbers are called floats in Ruby. They're called floats most places. Floats consist of numbers with a decimal place or a scientific notation. Pi, I don't know what he's referring to with negative 808.08 or 12.043e negative 04 are examples. Strings, good old strings. Strings are any sort of character, letters, digits, punctuation surrounded by quotes, both single and double quotes. Byte rate bad, byte rate bad. Oh, make the byte rate better. Both single and double quotes are used to create strings. See Lab 2021 and these cartoons are hilarious are examples. When we enclose the characters in quotes, they're stored together in a single string. Think of a reporter who is jotting down the mouth noises of a rambling celebrity. I'm a lot wiser, says Avril. I'm a lot wiser, says Avril Lavigne. Now I know what the business is like, what you have to do, and how to work it. Avril Lavigne, right? Quoting quote equals this. That is a dated reference. So we're just stored the number of teddy bear fee variable. Now we're storing a collection of characters, a string, the Avril Lavigne quote variable. The reporter sends this quote to the printers, who just happen to use Ruby to operate their printing press. Print Oprah quote, print Avril quote, print Ashley Simpson debacle. Okay. We are in 2005, friends. We are. Say something loud. Maybe he'll use it in his examples. Like what? Chunky banana? Chunky bacon. Chunky bacon. Is that a 2005 quote? Um, I don't have Lexdexia, but I'm pretty sure people think I do now. Symbols are words that look like variables. Again, they may contain letters, digits, or underscores, but they will start with a colon. A, colon B, or colon Ponce de Leon are examples. Symbols are lightweight strings. Usually, symbols are used in situations where you need a string, but you won't be printing it to the screen. You won't be printing it to the screen. You could say a symbol is a bit easier on the computer. It is like an antacid. The colon indicates the bubbles are trickling up from your computer's stomach as it digests the symbols. Ah, sweet relief. Chunky bacon! Chunky bacon! Constants. Constants are words like variables, and constants are capitalized. If variables are the nouns of Ruby, then think of constants as proper nouns. Time, array, and Bunny Lake is missing are examples. Bunny Lake. In English, proper nouns are capitalized. Empire State Building. You can't just move the Empire State Building. You can't just decide that the Empire State Building is something else. I think we can, depending on who we are. Ask King Kong. Proper nouns are like that. They refer to something very specific and usually don't change over time. In the same way, constants can't be changed after they are set. Empire State Building equals 355th Avenue, New York, New York. If we try to change the constant, Ruby will complain to us. Such things are frowned upon. Come on, seriously, chunky bacon. Chunky bacon. Chunky. Why do I want to say chunky? Chunky, chunky, chunky. Why did I read that as... Because that looks like an O there. And so my brain just went like that. Good old methods. Methods is a variable. If variables and constants are nouns, methods are the verbs. Right. Methods are used to attach. This is what screws me up. Because the word method gets used interchangeably with other things as well. If variables and methods are the nouns, if variables and constants are the nouns, then methods are the verbs. Methods are usually attached to the end of variables and constants by a dot. You've already seen methods at work. Front door dot open. In the above, open is the method. It is the action, the verb. In some cases, you'll see the actions chain together. Front door open, close. Front door dot open dot close, I suppose. We've instructed the computer to open the front door and then immediately close it. Front door dot is open. The above is an action as well. We're instructing the computer to test the door to see if it's open. This method would be door dot test to see if it's open. But the is open name is succinct and just as correct. Both exclamation marks and question marks are used in method names. Method arguments. A method may require more information in order to perform its action. If we want the computer to paint the door, we should provide a color as well. Method arguments are attached to the end of a method. The arguments are usually surrounded by parentheses and separated by commas. So, front door dot paint. Argument 3 red. The above paints the front door 3 coats of red. Think of it as the inner tube of a method that is pulling along, containing extra instructions. The parentheses from the wet, round edges of the inner tube. The comma are the feet around the argument. The comma are the feet of each argument. sticking over the edge. The last argument has its feet tucked under so they don't show. Interesting way of putting that. So in this case, are we talking about, I guess we're talking about the inner, yeah, we're talking about the inner tube as in you're kind of floating down the river type of inner tube. But, all right. Like pulling an inner tube, like pulling many inner tubes. Methods with arguments can be chained. Yeah, chaining. Door front paint 3 red, dry 30, close. The above paints the door 3 coats of red and dries in 30 minutes and closes the door. Even though the last method has no arguments, you can still put parentheses there if you like. But this is not the same as calling a function. There's no use dragging an inner tube, so the parentheses is normally dropped. Some methods, such as print, are kernel methods. These methods are used throughout Ruby. Since they are so common, you won't use the dot. Print, see? No dot. Class methods. Kind of did this before, but like the methods described above, also called instance methods, class methods are usually attached after variables and constants. Rather than dot, it's a double colon. Rather than a dot, it's a double colon instead. Door, colon, colon, new, colon, oak. Too much creatine, kids. As seen above, the new class method is most often used to create things. In the above example, we're asking Ruby to make a new oak door for us. Of course, Ruby has to have an understanding of how to make a door, as well as a wealth of timber and lumberjacks, those long, wiggly two-man saws. Chunky bacon, 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 chunky bacon. Global variables. Variables which begin with a $sign are global. $X, $1, $chunky bacon are examples. Most variables are rather temporary in nature. Some parts of your program are like little houses. You walk in and they have their own variables. In one house, you have a dad that represents Archie, a traveling salesman, and a skeleton collector. Another house, Dad could represent Peter, a lion tamer with a love for flannel. Each house has its own meaning for dad, and some houses have no dad at all. With global variables, you can be guaranteed that the variable is the same with every little house. The $sign is very appropriate. Every American home respects the value of the dollar. We're crazy for the stuff. Try knocking on any door in America and hand them cash. I guarantee you won't have to get the same reaction if you knock on a door and offer Peter, a lion tamer, with a great love for flannel. And offer Peter. Global variables can be used anywhere in your program. They never go out of sight. Yeah, we'll wrap the rest. We're gonna leave it there on global variables because Uncle John. That's a good place. That's a good place to stop it. Because I like this book. I really do. I think it's fun. I think it's interesting. But this is just our little slice of life. But hey, to everybody watching, or anybody watching, hope you had a good time. Hope you learned something. Hope you had fun at least with this. just makes me realize like we don't have enough just creativity in programming anymore. Everyone's like the mess around and play around and break and kind of play again nature of programming, I feel, maybe I'm wrong, is getting lost in people attempting to create the next biggest thing. But the next biggest thing is generally created through playing around. So, yeah. Have creativity like this. Get some chunky bacon stuff going. I hope everybody has a great rest of your day. And yeah, hope I get to see some people on the next stream. See you.